discuss on circular motion. So let's start with some terms like angular displacement theta, angular velocity, and angular acceleration. Well, we know in linear motion there are some formulas: b is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2as. Now we can take it in circular motion, which is v, angular velocity, omega is equals to omega naught plus alpha t, and theta is equals to omega naught t plus half alpha t square. Omega square is equals to omega naught square plus 2 alpha theta. Well, there are relation between linear and circular terms. S is equals to theta into r, omega is equals to A is equals to acceleration is to r omega or omega r, and then alpha is equals to acceleration. It's v is equals to r omega, and then acceleration is r into alpha. These are the relation between linear and circular motion. Now let's discuss on uniform and non-uniform circular motion. In case of uniform circular motion, speed is constant, and whereas in non-uniform acceleration it is not constant. In case of uniform circular motion, no tangential acceleration. Work done 0, angular acceleration, acceleration also 0. Now talking about centripetal acceleration, it will be AC is equals to b square by r, or putting the value of v, r omega, it will be r square omega square by r is equals to omega square r. And then in case of non-uniform circular motion, there is tangential acceleration. Relation present. Now then, in which is at, then the required acceleration will be a is equals to root under ac square plus at square in case of non-uniform motion. We will be discussing our motion on level road, motion on banked road, and motion of a cyclist. Well, in case of motion of level road, the frictional force provides the required centripetal acceleration. So F1 plus F2 is equals to mv square by r, and then the reaction balances the gravity. Well, in most level road, R1 is always less than R2, that is, the reaction of inner wheel is less than that of outer wheel. For maximum safe velocity, v is equals to root under mu r g. R is radius of circle. So now let's discuss on motion on banked road. Motion on banked road r sin theta and gives the centripetal acceleration, and r cos theta balances the gravity. So now for maximum safe velocity, v is equals to root under rg tan theta. Well, here we can find velocity by also the formula g r d by 2h. Now finally motion of a cyclist. In this case, the centripetal acceleration is provided by the frictional force. So we can also write mu rg is equals to mv square by r. This will give the relation b is equals to root under mu mg. This will give the relation b square is equals to root under mu rg. Well, when a cyclist turn around a curved road, it will turn by angle theta. So as sin theta will give the mv square r centripetal acceleration, and then r cos theta will be balancing the weight mg. So now in this case also it will be tan theta is equals to v square by rg. This is important formula. For here also tan theta is equals to v square by rg. Here also tan theta is equals to v square by rg. And then here you can find by formula v is equals to root under g r d by h. Well, here are two wheels and here is only one wheel, so 2 want to be in this formula. So now let's discuss on motion in vertical circle. There are 4 points A, B, C, D. A is the top and B is at the base. So there is one for tension mg cos theta is equals to mb square by r. Theta will start from this point, so you can now put values of theta and then find tension at various points. I will directly discuss on condition for keeping the body in motion. First, there is T maximum minus T minimum is equals to 6 mg. These are the relations. So now to keep body in motion. TA, VA, TV, VV. These are all minimums. Minimum. TA minimum will be 0 or near to 0. Then VA minimum will be root GR. TV minimum will be 6 mg. And then VV minimum will be 5 rg. Well, some questions ask directly the problems for this velocity, then B it will be V is equals to root under 3 rg. B is equals to 3 root under 3. Body slips tangentially from at as is equals to body slips tangentially from r by 3 from center. So when you have to count from the base, you have to add the radius here. Now to complete one, for example, it falls from this height and it has to complete one circle. To complete one round falling from h height is equals to 5r by 2. Here is the tension from the suspension, and it will be t cos theta outside, t sin theta to the inside of circle. This is the length of rope, and then this is the height from the center, and this is the radius. So now t cos theta will balance the gravity, and t sin theta will give the centripetal force. So it will be tan theta is equals to v square by rg. And then similarly rl sin theta, this is the theta, l sin theta will be r, and l cos theta will be h. In case of conical pendulum, time period is important, which is 2 pi is equals to t is equals to 2 pi whole root under h by g, or we can write 2 pi whole root under h l cos theta by g.